Hello everyone, welcome to experiment number 8 in lab 2 course, which is strength of material lab. Our topic today will be investigation of the normal stress distribution over the cross section of the plate with a circular hole at the center, of course when subjected to tension. So basically the objective of this experiment is to study the stress distribution at some distance from the ends to the center to the cross section of the plate with a circular hole at the center. So basically, if we have, imagine that we have our specimen, this rectangular specimen or this piece. In the center, we will have this hole in the center line of the force. So normally we will have a stress of a value force over area. This is called the minimal stress. But now, because of this hole, we will learn that there will be high stresses in the center and low stresses at the edges because of this stress concentration factor, which is the hole at the center. So our objective also is to study the stress distribution at some distance from the ends. So we can have one sensor in this point, another sensor at that point, and last sensor close to the hole, and then we will see that we have different values of stresses. So we know that there is some coefficient alpha if we divide the maximum stress value over the minimal stress value. Normally this value, if we have a small circular hole in the plate like the one we have, the nominal stress coefficient alpha is equal to 3. So basically we will have stress, maximum stress 3 times of the nominal stress, and we will see that with our results when we take the readings from the sensors. This is our specimen. We will compare readings of sensor number 1 at the edge, sensor number 3 at the edge, sensor number 2 close to the hole, and sensor number 4 far away from the center or far away from the hole itself. And then we are comparing these 4 values together. Table number 8.1 will show the dimensions and characteristics of the specimen, like width, height, diameter of the concentrator, modulus of elasticity of the sample, and everything. For theoretical calculations, we know that the minimal stress, or sigma 4, the stress at this point far from the hole, or we can say that without any hole, it will be the force multiplied by force divided by area. Force is delta B and gravity 9.81 because of we measure kilogram force, and for gravity it will be Newton. Area is B and H, width and height. For experimental obtained data, we can find the values of stress at any position by multiplying the modulus of elasticity with the readings of the sensor, or elongations, or we can say strain of any position. So modulus of elasticity and strain will give us stress number 1, 2, 3, and 4 at the 4 values. If you want to prepare our experiment, same as usual, we will install the support number 1, this one, and then support number 2 for preparation to tensile stress or tensile force, and we will fix our test piece clamps number 4, this element and that element, and then lastly we will fix our specimen number 5 in between, so that if we turn the knob to the right, we will apply tension on the specimen or in the sample. Of course, we need to attach the connectors and connect the wires to the computer so that we will be able to read the values of the sensors in the computer. So let's go and conduct our experiment. Good. So let us start and fixing or assembling our test machine. If you go to manual, it's available in Blackboard. The steps are given. So assembling in the manual, assembling the test machine. The experiment is carried out on the tensile machine, figure 9.14. For example, this is our machine. Step number 1, install the support 1. So as you know, if you go back to the table of elements, Number 1 is the support, and it has a photo. It shows that this is support number 1, and we need to fix it. As mentioned, install the support number 1 in holes 10 and 11. So I need to count 1 2 3 4 5 6 7 8 9 10 and 11. So I should fix my element, the support, at holes 10 and 11. So this is 10 millimeter pose, and this is 11 10 millimeter pose. I need to fix the support. So it's fixed. Good. Step number 2, we need to install the support with lever, which is element number 2 in the table of elements. And if you see the figure or the table, you will see that this is the support with a lever. Basically, it's a screw drive. If you turn this on, you will transfer the rotational movement into linear movement. Let us try. You see the length is increasing in here, and now you see the length is decreasing. So anyway, let us put it, and it's mentioned that install the support with the lever 2 in holes number 1 and 2. So this is hole number 1 and 2. So I will fix it in here. Same thing, we need the 10 millimeter bolts. Good. And you see we have this wire. It will be connected to this device at pin number 1. So I will fix this. And what is the meaning of this connection? This is a sensor to measure force. So when I turn this knob to the right, I'm applying some tension force. When I turn it to the left, I release the force. So anytime I apply some force, this sensor will be measuring the value of Newton tensile force. Good. Step number 3, insert the retention pins. These are the pins, and fixing the test piece clamps. These are the clamps. So I will take one clamp and one pin and fix it here, and then I'll take the second clamp and the second pin and fix it there. So now the setup is ready to plug in my specimen in order to apply the tensile force. Okay, so the last step will be fixing our specimen itself. So as you see, we have the specimen with a hole in the middle, hole in the center. But before we fix the specimen, let's go back to experiment number 1 and 2 and compare it to the situation of experiment number 3. So experiment number 1, we had normal sample and we applied a tensile force. Experiment number 2, we have the same specimen with the same force, but the force or the load was not in the center. It was shifted towards some side. So the force was, or the load was, eccentric. And now we are comparing a third situation in where we have the load is applied to a sample where we have a hole in the center, and we want to study the effect of this hole, and we know that it will cause some stress concentration in the middle. And now let's fix our specimen. So as you see, we can turn the knob on and off in order to control the distance. So we need more distance. Okay, I think I think, install the support in holes number 11 and 12. So we should remove this and instead of 10 and 11 we should shift it to 11 and 12 to have more space. So this is 11 and 12. Good. And this is our specimen. Now what is the bins? This is one. Good. And this is bin number 2. Good. So it's ready now, and we need to connect the sensor to be able to measure all longitude, all positions. So we have 1, 2, 3, 4 sensors, and we will be able to detect the stress concentration at this position far away from the circle, and another in this y-axis we have 2 sensors, one far from the circle and one close to the circle, and other one from the other side, and then we can discuss the differences between all values of stresses. And as you know, if we turn the knob on, so we are applying tensile force. You see it's under tension now. If we release it, it will be loose. That means we don't have any force. So let's go and perform the experiment. So for conducting the experiment, let's do the steps. 1. Assemble the test machine as described above. We already have our machine ready for the experiment. Number 2. Loosen the specimen by turning the knob on the lever to make sure that there is no load is applied. So it's relaxed and there is no tension on the specimen. Number 3. Run the software strength of material and select experiment number 8. So if I go to desktop, I will find the software and select experiment number 8, investigation of normal stress distribution over the cross-section of the plate with a circular hole at the center when subjected to tension. So double click, and as normal we have 3 tabs, one for the parameters, thickness, width, diameter of the center, and coefficient of sensors, the sensors coefficients, all of them, and 2, table of increment and stresses. When we do the readings, we will have our values appearing in this table, and lastly the results and the specimen itself. So as you know, this is our rectangular test piece, and we have this hole in the center, and we will measure. For example, we are comparing sensor number 1 at distance from the hole and sensor number 2 close to the hole, and the effect of, for example, sensor number 4 very far from the hole, and we will compare sensors 1, 2, 3, 4 data, all of them together, and here we will have our results. So if we go back to the manual, we need to click start on the software panel. So this is our before that, let's go back to the table of increments and let me click start. So the device is ready now. We need to put a force of 100 kilogram force and then click measure. So I will come back to here and I will add force up to 100 Yes, this is 100, and then I will click measure. This is the first step. Each time again I will increase 25 kilogram force and click measure edge each time. So if I come to the force, I will make it 125, yes, and then click measure. Another reading 150, and then click measure. Another reading 175, yes, almost, and then measure, and last reading at 200. Almost 200, and measure. So this table shows our readings, the 5 readings. This summarizes our results, and in the figure I can see that we know that there will be stress concentration close to the hole. At the edges 1 and 2 you have less stress, but this value of increase is increasing as we approach the center of the hole, and we have the results for the sensors 1, 2, 3, and 4, all of them. If I want to save this result, I go to menu and save. An Excel sheet will automatically be created in this file. Yes, this one. Double click. Yes, so we'll have our data. No, not this one. Let me cancel this and open the other file. Yes, experiment number 8, investigation of normal stress distribution over the cross section of the plate. And you have our data, our readings, and table for calculating equations, and table to summarize the results. Yeah, this will be the end of our experiment number 8, investigation of normal stress on a plate with a circular hole at the center when subjected to tension. Thank you for listening.